Uh, yes, yes, yes. Thank you very much, Professor Mitul Modi sir. Uh, Without wasting a time, I just share the screen. Okay. So, all of you can able to see this screen. Is it visible to all? And my voice is clear to all the participants. Hello. Oh, okay. Fine. So today we are all together here uh, to discuss about this electrical vehicle, that is the next generation transportation technology, and I am honored to have to talk on this particular topic. So let us start with the outline of this today's talk. So in this today's talk, basically we are starting with the basics of this technology. So we start with the basic of this technology. Then we'll see the powertrain configuration. Then we'll see the types and parts of this electrical vehicle. Then we see how to select the motor for this electrical vehicle and what are the already selected motor and their performance. We'll see the battery management system in this expert talk today. We'll see the charging stations and chargers for EV. We see that what is the history of this particular technology and how long we are in the journey of this establishment of this technology. Then we see the today's development, what is the current scenario and what is the Indian development in this sector of electrical vehicle. Then finally we see that how you as a student, as a BE electrical student, you can develop the career in this industry, because this is a fast and almost exponentially rising industry. Then we'll see what are the career courses offered, and then finally we'll see the Indian policies. Indian government has already done initiation to establish the charging station at various places. So what is the policy of this government on this particular technology? And then if you want to do this particular, if you want to establish a charging station, then how you can select the sites for that particular station. So let us start with the first basic. This is the diagram of the all electric vehicle, which is totally electrical. There will be no mechanical configuration. You can see from this particular diagram the main components of this particular vehicle is basically a electrical motor, which is the heart of this vehicle, without which we cannot have a efficient system, because it is the most efficient system. Then we have a battery pack, second most important part of this electrical vehicle. You can see in this particular figure. Okay, this is the overall battery pack. Okay, and that provides the DC supply that converts into the AC supply via the inverter, because the motor requires the AC supply, and via inverter, this is high power inverter. Here we use high power inverter and high efficient inverter. Then there is a onboard charger here. There are various configuration of this charger. We'll see later on this expert talk today. And then we'll see the DC to DC converter, because the required voltage level at various stages are different. So we require DC to DC converter for a different voltage level at different places. So here is the DC to DC converter. This whole system will heat it up when you run this electrical vehicle. So it is very important, specifically for this part and this part, we required a cooling system. Apart from that, we required some controllers to control all these different components and to see on your screen various status on your driver screen. Apart from that, power electronics controllers are also convert to, for inverter operations also it is required. Okay, and the other controllers like some microprocessor based controllers are also will going to be used in this particular motor. So let us start with the first component of this electrical vehicle, that is electric motor. So there are various choices here. Basically, what is the function of this electrical motor? The function is to provide the torque to the vehicle. This is the main function, that it provides a torque to the vehicle by utilizing the electromagnetic fields, energy supplied by the battery, and this torque will be controlled by controlling the current flow via the battery. Okay. Why we go for electrical motor? Obviously, it have a very high efficiency, more than 90% efficiency as compared to the IC engines, and that is the reason that we are efficiently utilizing the energy. Apart from that, it also gives you the green energy. It also utilizing the electricity, so fuel consumption will be zero. So we have a shortage of fuel in next decades or next century. We have a very much shortage of this fossil fuel. So that is also one advantage. Apart from that, why electrical motor? Because electrical motor can efficiently control the torque, and it even deliver the torque at zero speed. That is one of the very important thing which is possible here. There are different motor setups available in this electrical vehicle. Right now you can see this particular figure is actually 4 motor setup. Okay, this is a 4 motor setup configuration. So there are different motor configuration setup will be there: single motor configuration, single motor setup, dual motor setup, and 4 motor setup. There are different way of to control or driven this vehicle wheels. So that is called powertrain. So there are different powertrains are there. One is the centralized single motor driven. So you only have a single centrally single motor at the set. I will later on see all this configuration in detail. And then one second is a distributed motor driven powertrain. Right now you can see here is a distributed multi-motor driven powertrain in this particular figure. So you can see there are 4 motors for all 4 wheels. Now selection of the motor. When you select the motor for electrical vehicle, we need to see this parameter: power density, efficiency, controllability of this motor, how you can efficiently control this motor, how much reliable this motor is, and what is the maturity of this technology. Because when the motor is new, when the motor is invented, technology is not that much mature, so the research is not that much of level. So we need to see the maturity of the technology also. And finally, the main concern is the cost. So when we compare all this motor like DC, induction motor, permanent magnet, synchronous machine, and SRM, we'll see that power density is very high in permanent magnet type motor because of the usage of rare earth magnet. Because of the usage of rare earth magnet, here will get very good power density. Apart from that, it also delivers the very high efficiency. In terms of reliability, SRM will be much higher, and this induction motor is also good at a reliability because it's a reboost motor. Apart from that, cost, if the cost is concerned, these two are very low, induction motor and SRM motor. Here the cost will be high because of the usage of this earth magnets. But if you see the comparatively, these 3 points are very controllability is very good, reliability is very good, and technology is also mature. So we can ignore this last point right now currently, because when the competition is high, at that time we need to think about the last point also, like a cost. But right now that technology is not at much that level, so we can ignore this last point, that is a cost. Now let us see, as I told, there are different powertrain configuration. So this is the powertrain configuration. This first one is a single motor driven powertrain. So here the only one motor is there, and this is a mechanical system, differential mechanical system is used, which will whatever torque will be produced by this motor is differentiated here at these two wheels, and these two wheels are controllable via this motor and via the differential mechanism, and this is a battery. So this particular is called a single motor driven powertrain. Tesla Polestar 2 has used this technology, and using this technology Tesla Polestar, generally actually this is the first version of Tesla Polestar. The second version, which used the two motors, has actually got as after the first version, second version has used two motors, and we'll see that in the next in this PPT later. And this will give you the range of 425 km at the top speed of 160 km per hour. Okay, then this is we can say the dual motor driven powertrain. Here there are two motors and two mechanical differentials are used. Okay, and there is a battery. So here these two front wheels as well as this back wheels, both can be controllable, and both can be both torque of both this part can be controlled at a simultaneously. Tesla Model 3 has used this technology as this powertrain technology, and it will deliver the speed. It will have a range of 576 km for one charge, single full charge, and it gives the top speed of 260 km per hour. So these are the two powertrain technology available. Then this is a third technology, that is 3 motor powertrain driven technology. Here you can see there are 3 motors, 1, 2 and 3, and you can clearly see that there is no mechanical system here in the back wheels. So there is no differential we have used in the back wheels. So this is fully electrically the torque is fully electrically controlled. Here the torque is actually electrically as well as mechanically controlled. So the torque is finally controlled mechanically here at this front wheels, and this back wheel the torque is fully electrically controlled. That is the biggest advantage in this 3 motor power driven technology. So the Audi e-tron S has used this technology, and they have recently launched this model. And finally, the last and one of the the research powertrain technology is a 4 motor driven, where you eliminate totally mechanical. You are eliminating total mechanical. So it is totally electrical now. So you are eliminating total mechanical. So it is full electrical vehicle, which is I have shown in the first figure of this presentation today. Full electrical. So what is this advantage? You can see this first figure. Right now I am controlling 20% this wheel, 25% energy given at this wheel, 25% energy given at this wheel, and as I want to control this wheel much, so the energy consumption here is 30%. And here I can control all these 4 wheels as per, so we can have a smooth moving of the car, because I can control all these 4 motors torque very efficiently and very reliability as well as very smoothly. So when I want to move this car slightly away this side, I do not require torque much. I do not require to control this much of this. So I want to control this vehicle, this wheel and this wheel. I want to control this wheel much because I am moving at this side. So this is 48% energy is consumed, and this is controlled more efficiently, this particular wheel. So this is fully electrically controlled technology, that is 4, or we can say the 4 motor driven powertrain. 4 motor driven powertrain. So in this particular figure, this is 4 motor driven powertrain, which is have a total control on the torque, which is totally electrically controlled. There is no mechanical system because the motor is directly in fit on the vehicle. Okay, that is These all are the power driven technology, or sorry, powertrain technology of this electrical vehicle today. Now let us see the selection of the motor. So let us see the selection of motor and how people are selecting the motor. So initially, when the technology is not that much evolved, and at that time we have started with initially with the brushed DC motor, where there are different problems, because the first is heating problem, because and sparking problems. Apart from that, it has poor efficiency, sparking problem, heating problem, poor efficiency, wear and tears. So life is less, motor life is also not much long, less efficient. So these are the problem with this technology. This Fiat Panda Electra has used this technology initially, brushed DC motor, and they have used the configuration DC series motor. DC series brushed motor have used in this particular vehicle, that is Fiat Panda Electra. Then technology is slightly evolved, and we are eliminating this problem of brush. So this is brushless DC motor, where the totally the commutation is totally electronic. So here we have commutations is totally electronic commutations. So we are eliminating the brush need. So we'll have a very much now efficiency is very high now. Efficiency is improved. Okay, or control is improved. Power density is also good. Okay, so these are the advantage of this brushless DC motor, and that's why this technology is eliminated, and this is now in use. So this particular Toyota Prius has used this brushless DC motor in their vehicle. There are some limitations of this technology. Complex control is one of the limitations. Complex control, power electronics control is very complex. Okay. Apart from that, there are other concerns. That as compared to price is also high. Okay. So these are other, and there are other technical concerns of this brushless DC motor technology. So people are moving towards the permanent magnet synchronous machine, that is PMSM motor. So PMSM motor have a good success as a electrical vehicle motor. It has a good success, and this particular PMSM motor has used in this Chevrolet Bolt EV, Ford Focus EV, BMW i3. Recently they have used PMSM motor. Apart from that, there are many of the different multinational automobile sector has used this PMSM motor nowadays. But no, this is not, we are not limited to these three motors. Let us see other motors also. Let us talk about the induction motor. Because of the nowadays we have a lot more research in this area of controlling of the induction motor speeds, and because of that we are able to achieve low starting torque by vector control method or by field oriented control. And because we all know that induction motor have a very high starting torque, and that has to be limited. When you start the car, we need to control the torque because we need to start smoothly. So, and that's why there is a problem to use this induction motor. But because of the technology has grown very fast and research is very fast evolving in this induction motor area, now we can able to achieve low starting torque with the vector control method or full oriented control method, and hence this Tesla Model 5 has used these machines in their technology. Then the research is going on the synchronous reluctance machines. Synchronous reluctance motor. Synchronous reluctance motor. This is one of the research going on this particular machines. You can see the construction. Here the problem in this particular vehicle is, once again there are some different issues, like efficiency is also good, but the issues here is that losses are there in this motor, iron losses and hysteresis losses. Here we can eliminate the losses part by the design. You can see the design of this rotor. This is synchronous reluctance motor, and this is also in trend of research to use in the electrical vehicle. Apart from that, this another motor is axial flux ironless permanent magnet motor. Have a special configuration. These are special electrical machines. Okay. And one of this induction motor is also used in Toyota RAV4, this particular, and Renault, and this synchronous reluctance motor is used in Renault Cube. Okay. Now let this all are about motor selections, how you select the motor, what are the criteria you have to consider. I am not going that much of detail right now because these all are very high deep topics. I can spend 2 hours for only DC series, 2 hours for brushless, 2 hours for PMSM, not 2 hours, at least 15 hours for PMSM motor, but I am not going that much deep. So let us see the BMS, that is battery management system. So when you talk about the battery management system, let us understand what is called module. So when you have a different cells, you combine the different cells like this, then it makes, when you connect in series and parallel, this is in series and parallel, you can see the series connection as well as the parallel connections here. So that will make a module. Okay. And when you have a different 1, 2, 3 and different modules you have, it makes a pack. Okay. So when you have different modules, it's create a pack. And what is the main problem is that when you have a pack and you have a number of cells together in series and parallel configuration, it is very difficult to manage the battery level, because one battery at this level, second is at this level, third is at this level, fourth is at this level, this level. Okay, so the level control is more complex when you have a battery pack, and that is where we required complex electronics control for this battery management system. So we required to manage this battery. So what we want to manage, so you can see this particular figure. To achieve the peak performance and a long life of the battery, we need to have 3 things to do. We need to continuously monitor the temperature of this pack. We need to see what is the state of health. What is the state of health? I will discuss it a few minutes after. And state of a charge. So these things we need to take care, and I will explain you this BMS system in brief in this next slide. So this is a BMS system. Basically, this is algorithm. This is the maybe AI based algorithm, maybe any conventional algorithm, maybe some fuzzy based algorithm. It may be anything. Here there is one control algorithm. One control algorithm will be there in this battery management system. Basically, it monitors. These are the 3 basic parameters which requires to monitor to achieve or to see these 3 outputs. V, which is the voltage. So when there is we have one cell, so we measure the voltage of these cells. Okay. Then we make the overall voltage. We also overall pack voltage. So we have different cells. So we monitor the second voltage, and the third voltage and fourth voltage, and also overall pack voltage also we are going to measure. And apart from that, we also need to measure temperature. So we have a temperature sensor here. Okay, we have temperature sensors also, which give you the temperature of these cells, different temperature of the cells. Apart from that, we require to measure the currents also, drawing from the each cells and overall pack. So by using this different V, I and T, I produce, or output will be produced by the battery management system, that is SOC, that is state of a charge. We we see in the mobile that 59% battery is remaining. That is nothing but a state of charge. This much charge is available now. That is called state of a charge. What is the state of a charge now? All of you have a indication on the mobile. We all frequently see, okay, 50% battery is there. Okay, so 75 is, 85 is already used. So what is state of charge? So that is called a state of a charge. Then state of a health. We often see the state of a health. Our mobile will not showing the state of a health. But what is state of a health? When we purchase any mobile, let's say I just give you the example of mobile. When you purchase any mobile, first what we see, that when initially we 100% charge this mobile, it will run for 2 days. Let's say, that's just for example. And then next time when after 1 year when I charge 100%, it only 1 day it will be used, and the battery will drawn out. So that is called state of health. Now the health is 50%. health of my battery is now 50%, because when I purchase, when it is initially designed, it is designed for 2 days for 100% charge for different for continuous. By considering, there are different parameters to consider. Let's say I am considering the parameter that continuous movie watching. When I charge the mobile 100%, when I continuously watch movie, it runs for 2 days, let's say at the initial stage when I purchase, when I manufacturer. And then after 1 year, I charge 100% and I continuously watch movie for 2 days, it only have a 1 day of usage. So that is a state of a health of this particular battery. And so we are continuously monitoring the state of health of the battery pack and the cells. And then state of energy, that is one another parameter. And finally we also see the faults and status. So because many times there is a fault inside, that also we need to monitor. So basically the function of the battery management system is to have a charge balancing, because if I want to improve the health, I have to manage the charge. I will discuss you this topic in detail in the next slide. So this is a charge balancing we require to improve this overall performance of the battery. And then I also need to control, I also need to see the thermal management, because of the problem of thermal runaway. Because when you operate the battery, and if the battery is heated up, and if you are operating outside of these temperature range, there is a battery have a temperature range. So this is a green range, so you need to operate the battery at 0 to 40 degree only. But if you are operating the battery above 50 degree, 60 degree continuously, then there is a thermal runaway and battery will be fire. And you have seen the issues and nowadays here in this technology of the battery management, that this battery caught fire. So when that's why the thermal management is also one of the important output of this battery management system. You need to see the thermal status of this all the battery cells as well as the pack together. So how before going to this topic in detail, let us see how we can maintain this temperature range. So if you want to maintain the temperature range, we require a coolant into the system. So basically we use air coolant, water coolant, oil coolant, fragrant base coolant, or refrigerant also we can use. So let us see now active balancing and passive balancing. So I already told that each cell have a different level. When you charge the battery, when you discharge the battery, they are not simultaneously at the same pace. They will charge and discharge. Some have a faster charging, some have a slower charging. Some cell will be, because all two cells of one manufacturer have not similar charging and discharging rate. If you are one manufacturer and you produce a two cell, one and cell and two cell, you are a one manufacturer and you produce a two cell, then this two cell have a different charging and discharging. It will not same always. So they are almost similar, but they are not exactly the same. So one will be charged faster, one will be charged slower. Okay, so what happens at the same time when you discharge it, one will be discharged faster, one will be discharged slower. So because of that, one who is drawn completely will reduce the output, because it will block, because they are series connections. So one will be open, everything will be open behind it. Are you getting my point? Are you getting my point or not? You have a different cells in series. Let's say this is open, then nothing will be connected now. So one cell which is totally empty will actually empty all behind it in that particular series string. So that will improve, that will decrease the efficiency, that will decrease the performance, that will decrease the output level of my battery. So what I need to do, I need to synchronize all these cells charging and discharging at the same pace, so that I can efficiently utilize all the cells and I can give you the maximum output from the battery. Are you getting my point? All of you, all the candidates over here, are you getting what I am saying? Hello? Are you listening? Are you listening to me or not? Hemangi, I think you are from R.G. Patel Institute of Technology. Am I right? And I was a professor at your institute in the past. I have worked over there 3 years. Okay, so I know the level of you are I think very sound, as I think you will understand this. I definitely because they have very competent staff over there, so definitely I hope that you will understand what I am saying. So what I have to do in active, and these are the two methods, active and passive balancing. These are the two methods. So what in both the methods, what I have, my target is to have a same charging of all cells and same discharging of all cells at the same pace as most as possible. So there have two technology we have for to do this task. One is active balancing and second is a passive balancing. Obviously in the passive balancing, what we do is, let's say one cell is charging at this much level and second is charged at this much level, and let's say one is discharged at let's say this much level and one is second is discharged at this much level. So what I do, when I have one cutoff, this is my cutoff. So when a cutoff is achieved in a one cell, I deliberately release the energy of this cell in passive element. This is one cell, this is the second cell. I have achieved cutoff in one cell, but I have not achieved the cutoff in this particular cell, because this particular cell is at this much charge right now, and this is discharged up to this level, and I have achieved cutoff. I have achieved cutoff here, but I have not achieved cutoff here. So, but I have to maintain this synchronism in all cells. So to maintain this synchronism, I release this energy, this much energy in passive elements from all these, all, let's say one cell, second cell, third, fourth, fifth. One is at this level, 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 one is at this level. My cutoff is this. My cutoff is this. So this, let's say this is achieving the cutoff. So this is not achieving, this is not achieving, this is not achieving, this is not achieving. So I release this energy in passive. So these all are in synchronism, in discharge. Okay. And similarly synchronism in a charge. So by a passive element I am doing these things. So this is not a good method, because we are wasting the energy in the passive element. So this will not give you the full output, because you are not utilizing the full of it. Actually you are wasting this energy in the passive element to make it synchronize. Are you getting my point? So that's why the passive balancing is not an efficient method, and hence right now technology is about active balancing. Are you getting? Active balancing. So what is this active balancing? I will show you this in this figure. What I do is, let's say this cell is this much charge, this cell is this much charge, this is at this level, this is at this level, and this is, and my cutoff is, let's say this. Okay, so what I do, let's say now there is excess energy here, excess energy here, excess energy. So I utilize via this controller. This is a microcontroller or microprocessor based, any controller or digital signal controller, whatever be it is, let's say FPGA, any high end controller. Okay, what I do is, I have this excess energy I stored in this tank, that is a storage cell. Okay, and I utilize later at the time of charging equally to all. So excess energy I cut, this excess energy I utilize and stored here, this excess energy I utilize stored here, this is already this much energy utilized here, this much energy utilized here and stored it, and now cutoff is achieved. So now charging is started. So I have this stored here. I now equally I provide to all. You are getting my point. एकदम सिंपल एग्जाम्पल આપું. 3-4 છોકરાઓને મેં રેસમાં દોડાવ્યા છે. મારે 4-4નો પહેલો નંબર જ લાવવાનો છે, કોઈની પાછળ આગળ કરવા નથી. આ છોકરો આટલે પહોંચી ગયો, આ છોકરો આટલે પહોંચી ગયો અને આ છોકરો આટલે પહોંચી ગયો. તો આને મેં આની એનર્જી મેં અટકાવી દીધો અહીંયા, આની એનર્જી મેં એને સ્ટોર કરી દીધી અહીંયા, અને આને અહીંયા આવવા દીધો. બરાબર છે? અને પણ હું ચાર્જિંગની ડિરેક્શનમાં બતાવું છું. એકચ્યુઅલી એક્ઝેક્ટલી આવું ડિસ્ચાર્જિંગની ડિરેક્શનમાં થાય, આટલે મારો કટ ઓફ છે, આ આટલે કટ ઓફ પાસે માની લો કે આવી ગયો, આ નથી આવ્યો, તો આની પાસે આટલી એનર્જી છે, આની પાસે આટલી, તો આઈ વિલ સ્ટોર ઇન ધેટ, એન્ડ when goes back I will equally distribute it to all. એટલે પાછા રિટર્ન આવતી વખતે બધાને ઇક્વલી ડિસ્ટ્રીબ્યુટ કરી દઉં, એટલે બધા સાથે જ અહીંયા આવે. સો what I understand what I'm saying? Are you understand what I'm saying? Are you getting what I'm saying? આપણે શું કરીએ છીએ કે ચાર્જિંગ અને ડિસ્ચાર્જિંગનો રેટ બધાનો સેમ રાખીએ છીએ. વી આર બેલેન્સિંગ ધ રેટ સેમ, સો દેટ વોટ એવર જો એટલે જ્યારે ડિસ્ચાર્જ થાય છે ત્યારે માની લો કે આ પહેલી ડિસ્ચાર્જ થઈ ગઈ, એન્ડ દેન ઓલ અધર્સ આર નોટ ડિસ્ચાર્જ એટ ધીસ, દે આર ઓલરેડી હેવ અ ચાર્જ. So I utilize this charge and stored in the stored cell. storage cell. And when, so I utilize this, so this is also achieved here. આમાંથી આટલી એનર્જી મેં લઈ લીધી તો આ પણ આટલી આવી ગઈ, આ પણ આટલી આવી ગઈ, અને આ પણ, આ બધા સાથે આવી ગયા. ઓકે, અને આ બધી એનર્જી હતી તે મેં અહીંયા સ્ટોર કરી દીધી. હવે જ્યારે ચાર્જિંગ સ્ટાર્ટ થશે, આઈ યુટિલાઇઝ ધીસ એનર્જી ઇક્વલી, એટલે પાછા બધા ઇક્વલી ચાર્જ થવાનું ચાલુ થશે. ગેટિંગ માય પોઈન્ટ? આર યુ ગેટિંગ માય પોઈન્ટ? આઈ ક્લિયર ધ સ્ક્રીન. લેટ્સ સે ધીસ ઇઝ અચીવ ધ લાસ્ટ સ્ટેજ, કટ ઓફ સ્ટેજ. હવે આટલી એનર્જી છે, આ યુટિલાઇઝ કરી દઈશ આની અંદર, આની આટલી એનર્જી આની અંદર સ્ટોર કરી દઈશ, આને પણ આટલું કાપી રાખીશ અને આને અહીંયા પહોંચાડી દઈશ. આટલી એનર્જી આઈ વિલ સ્ટોર ઇન ધીસ સેલ, આઈ ઓલ્સો સ્ટોર ઇન ધીસ સેલ. So then after when the charging is start, I utilize all equally to all this, so everything will be charged in the synchronism. Similarly in the discharge. Okay, getting my point, all of you? This is called active balancing. So this is an important algorithm have played a role over here. If your algorithm is more efficient, then you will get a more same rate of charge and same rate of discharge. Okay, so this is called active balancing. This technology is used in the electrical vehicle. So these are the, you can see the most suitable battery is lithium ion battery because of its higher density, higher power density, and the base motor is a permanent magnet motor. So you can see this is a Tesla motor, and in the back wheel this is a dual Powertrain configurations, and that is installed in Tesla motors. And this is a battery pack which is installed on the chassis of this motor, Tesla motor, that is Model S. This is lithium ion battery pack. Okay, and when you select this, when you select the battery, you need to see two things: specific energy and specific power. So the lithium ion battery have both criteria coming into their pocket. So it have a very good level of specific energy per kg. So if I have a 1 kg of battery lithium ion, it have a capacity of 150 kilowatt hour. That is the specific energy it has. And at the same time it delivers for 1 kg delivers around 300 watt power. So this have a 150 watt hour specific energy, and it can able to deliver 300 watts of power for 1 kg. So that's why this term is very important: specific power and specific energy. So if these two terms are higher, both terms are higher, this is a good battery because it have a, for 1 kg it delivers more power as well as it also delivers more ampere hour. That's why this is the first choice, and then second is this, and then third is nickel cadmium. Okay, and it is not necessary that lithium ion is suitable for every application. Like we cannot say that these two criteria, the specific power and specific energy, is the only criteria. This is for electrical vehicle only. For let's say you have a mobile application, then the criteria is different. Let's say you have some another model of the machines, then the criteria is different. But mostly this is the main criteria. So this is how you have to select the battery for the electrical vehicle. Are you getting, all of you? Now this is the why we can now afford this electrical vehicle, because of this reduction in the price of the battery. So nowadays, previously in 2018 we have a $179 for 1 kilowatt hour of electricity from the battery, and now we have only $100. If you want to utilize 1 kilowatt hour from the battery, it only have 100 hour or less in 2025. So in these recent years, this is a prediction. Okay, so other components of the electrical vehicles are inverter. As you know, this convert DC to AC, and also it requires to to have implement different algorithms. And this is a DC converter because the battery voltage will go down to 12 volts for the wiper applications, some infotainment applications, mirror control. So in motor there are different voltage level required at different stages. In motor you have a wipers, you have some CD player, you have a tap, you have some mechanism in your machine in your inside your vehicle. So for that different voltages are required. So we have different DC to DC converter at different applications in the electric vehicle. Now let us see about the onboard chargers. So chargers are very important, because when you have long charging time, then you are it is not waste of time. You have a waste of time when you have a long charging time. So there are different charging configuration the company will offer. One is, if you don't want to purchase any basic charging station, then you have a basic home charging that is given by when you purchase any electrical vehicle, they will provide you this particular charger. That is a level 1 charger. I will discuss about this, what is the configuration of the voltage and everything. Right now I just pictorially represent it, and later on I will give you the ratings also. Then second is the EVSE, home charging. This has to be, if you they are offering you, when you purchase the electrical vehicle, they will offer this charging system, and you to purchase it, and they will install at your home. This is a very fast. It will charge in 2 hours or your vehicle. This will take around more than 10 hours for around 50 kilometer only. So when you charge 10 hours, it will only go 50 kilometers, or let's say more than or around 100 kilometers, not more than that. Here in 2 hours you can go up to 100 kilometer very easily. And this is the level 3, that is a DC fast charging stations, which is located at different places by the government or by the private sectors, and that will only in 20 minutes it will fully charge your battery. So let us see each of one. So this is normal charging, 15 ampere plug. You can install at your home via electricians. Any electrician will do this task. Then the second level, LAKH AC chargers. It will use 230 volt AC supply. These all are taking long time. Then you have a Bharat AC chargers, which have 3 guns of charge. Each one have a 3.3 kilowatt gun. So using these 3 guns, you can charge fastly, and you can charge in a less time. Mahindra E2S and Tata Tigor will offer this type of Bharat AC chargers. It costs around 50,000. Then fast chargings. These all are AC chargers. These all are AC chargers. Then the most upgraded version of the AC chargers, high capacity EV models they are using in India. This is the fast AC chargers. It will have a 77 kilowatt to 32 kilowatt chargers capacity, and it costs around 1,35,000 for the charger only, not for car. Now DC chargers. DC chargers have 3 configurations. One is low voltage DC chargers. Only 120 volt DC supply is enough, and it can draw 100 amperes from this source. Then level 1 chargers have 48, 60 or 72 volt, and it has a 200 ampere capacity. So it is a very fast. Okay. And this is most popular in India, 200 ampere, 48, 60 volt and 72 volt configuration. And the next level is level 2 DC chargers, which is in the research stage, and in the different countries like US and Europe, they are announced the decision, or Nissan has announced the decision to make this use of this particular level 2 chargers. Have a 150 kilowatt of capacity, and it can charge maybe it takes more than 200 ampere. Mostly, as per my knowledge, it used as per here it is used the 100 volt, but I think it will also draw more current than it is possible. It may be 220 ampere or 250 ampere around. Rating is not right now given, but it is having a 100 volt DC supply, and maybe it have a 200 ampere of or 200 more than 200 ampere of current capacity. So then and then it will fastly charge. Nissan has announced to use this level 2 DC chargers. Maybe it will charge in 10 minutes or 5 minutes. Now we'll slightly go back, because this all is the latest thing I have discussed with you. Now let us be going slightly back. So history we'll see. So the history started from 1828, where first small scale electrical car has been developed in the US. Then 1832, the first crude electric vehicle is developed, and then in 1891, first electrical vehicle debuted in US market. Okay, and then in year about 1968 to 1975, the gas prices will soar in the US. So at that time, at the same time in 1971, over the moon with we have the US have NASA have used this lunar rover, which is based on electric supply. So it is electrical vehicle basically, and that is successfully run on this moon. So that is one breakthrough. And then I have skipped one of the milestone in between. So I come to 1997, where the first mass production of the hybrid electrical vehicle will be announced and Toyota have released the this announce of the first mass production of hybrid vehicle in the US. And then in 2009 and 2013, they have developed the nationwide charging infrastructure in all the America. Around 18,000 residents commercial has benefited with this. And then in 2013, the price of battery goes low. The battery cost goes low because of the inventions, and it is goes by 50%. So if you are purchasing 20,000 battery pack, then it is now 10,000. It is goes 50% low. So because of that, this technology has gained pickup, and in 2015 they have developed the electrical car based on the solar chargers, okay, which only utilize only 30 to 60. So over by nations, they have only 30 to 60% uses of oil. Then mostly they have used the electrical vehicles. Now in India, we have latest development. In India, we have announced to have a 9 lakhs electrical vehicle play on the Indian roads in the 2025 around. Also, center has asked the all state to replace all the diesel buses with the electrical vehicles. So that is one of the breakthrough in Indian development. Honda has filed one patent of Yugo electric scooter in India. Apart from that, electrical vehicle to drive auto cabs by this industry have 70,063 crores development in next 5 years. Okay. And HHI have done MOU to create explosive free battery. This problem will resolved by the HHI, and they have make agreement with the different creators to produce the explosive free batteries. These are the hybrid vehicle where you use the fuel as well as the electricity, but now almost this will be old technology, this plug-in hybrid vehicles. And let us see now let us come to a very important point. It is what are the branch which is suitable for electrical vehicle career in this electrical vehicle. So basically, first priority is electrical engineering, because we are the one who tests the battery, we are the one who can control the motor, we are the one who can create a driver circuit, controller circuit, we are the one who can develop the wiring, we are the one who can develop the powertronics. Even we are because now the electrical vehicle is fully electrically controlled, so there is no need of mechanical powertrain. So usage of mechanical is at that bottom, because they have only part design and thermal management. If let's say I want to use refrigerant, if I want to use some cooling mechanism, then there will be come into the picture. But they have a role. I cannot say that they do not have a role. They have a role. Computer science people have also a role, because battery management system algorithm and different IoT system also we have used to see the status of electrical vehicle on the road. So that where the computer science comes into the picture. Chemical engineers also come into the picture because of the battery development, lithium ion and the recycling. And automobile engineers also come, but they have a less role to play because of mechanical engineer. And mechatronics have also a role to play because of the powertrain components, but that also can be done by the electrical engineers also. And ECs also have some sensor circuits they can develop, and so that you have a different status of the vehicle on the dash of your vehicle. So if you want to develop the career in this industry, how you will develop this career in this industry? First, you have to create, when you will study MTech or BTech, you need to create a very strong background in these two electrical and electronic subjects. You need to have a good command on machines, power electronics and drives. Once you have a good command in the 6th semester or 5th semester or in the MTech first year, then in the second year you can take a project on converter, BMS, speed control, and then you can start an internship in the summer to the different electrical vehicle companies, and during the internship you show your work and impress the company, hire employees, and you can get hired over there. This is the one way you can enter into this sector. Different companies which are hiring these electrical vehicle technocrats is Tata Motors, Mahindra, Maruti Suzuki. This list up is not full. There are many to come here. Bajaj, Toyota, Honda, Ford, Ola, Tesla, Mercedes Benz, all are require this kind of technicians or engineers. So at Ganpat University right now we are offering electrical power system, and we also provided learn with earn opportunity, so that student can learn and earn both. We are offering TSIP to the students who are meritorious and sharp students. Apart from that, we have a good. We are also going to offer the MTech in electrical vehicle. We are in the planning to offer this subject in this year, because by looking the demand of the market and the development in the technology. So there are two courses we have right now: power system and the vehicle, electrical vehicle. You can select. At our places we have all the industry focused syllabus we have designed, and we have dedicated designation work in the final year where you can go into the industry, and we have dedicated laboratories and research facilities over here. What are the challenges to this technology? One is the range inaccessibility. Range is not more, so range inaccessibility is there, because when I have petrol, I can go up to I can go easily up to 700 km or 800 km by full tank charge. If I have a capacity of 30 liters or 40 liters tank capacity, then I can go at a good range. So range inaccessibility is, the petrol is less. Here the range inaccessibility is less. How range I can cover with in a single charge? It is 100 km, 200 km or 300 km, because battery life health is I don't aware of it. That what is the battery health? And battery health is year by year decreasing, state of health of the battery. So 1 year when you purchase the electrical vehicle, the first year you go 300 kilometers for a single charge. Next year only 200 kilometers. In next year you are 100 kilometers. So year by year you are annex, and you have annexity that how far I can go with a single charge. You don't sure about it. Okay, so that is one thing. Initial cost is there. It is very costly. The vehicle cost is around more. When you purchase a moped, it is cost more than 1 lakh rupees because of this battery cost and the charging time. It have a lot of charging time. Though it have 20 minutes, it's a long time, because in a fuel in a 2 minutes the fuel will be charged in your vehicle. Here it is 20 minutes, so it is 10 times higher time in electrical vehicle. That are the challenges. These are the challenges we have. Apart from that, other challenges that load on power grid, because when you have all the electrical vehicle, what will the grid is able to tackle this harmonics or whatever with the loading, immediate loading or peak hour loadings or anything. All these analysis we require to do, or to develop the grid to be capable of delivering these challenges. And the lack of charging infrastructure is one of the issues in India. Apart from that, different absence of component of the EV which are eco-friendly, because many of the components are not eco-friendly. So Indian government have a different policy for the charging station, and they have planning to reach 25% of all new vehicles sell by 2024 on the road. They have policy that wherever you are placing any charging station to your mall, then you have to see this all criteria. One is it should be benefited to malls owners and shop owners. It has to be benefited to tenants and visitors. It also have to benefit to retail customers, and it has to have a social benefits. So when you planning this is you can see the developed charging station at the mall ground floor. This is a mall ground floor, and you need to print all these things. This is very compulsory. This is compulsorily you have to do all this part painting and signboards. And then safety planning is also required, because whenever there is an explosion of any car, you have a fire system. Okay, So the safety is one of the important concern when you know place the charging station at your ground floor of your mall. Electrical layout should be properly taken. It should be very near to the vehicle so that you know it can be managed easily. So here it is written everything. I am not going to read it. And you have to provide basic amenities like water. You do, when somebody is charging at your mall, it takes 20 minutes, let's say. So for 20 minutes you have to provide water, snakes, paid snakes, whatever it be, because there's a too long time. So this basic amenities you have to provide. And when you have when you are planning to establish any charging station, we need to select the locations, because the charging station should be optimally located from the distance of your main supply panel. If you have a main supply panel, then it should be 50 meters around it. Let's say your main supply panel of the GEB or DGVCL, then in the 50 meters it is advisable to use charging station in 50 meters from this. Okay, visibility should be there, so anyone can enter, can visible this charging station. Okay, it will be easily accessed because car can come over here and pass easily. It should be easily accessed. It will be safe to all drivers. It have a good connectivity of Wi-Fi and other things, so that I can see the status on my mobile, that how much it is charged and how much it is discharged. And this is the workplace. When you want to install the charging station at your workplace, your company or your university, then this is the guideline they have provided. I have taken from the source of Delhi government website. So again, you have to minimize the distance from the main supply service of electricity. We need to have a proper electricity connections. We need to have a transformer of around, if your demand is increasing, your university demand is increasing more than 100 kilowatt, then separate transformer is needed. Okay, we need to do metering separate, cabling separate, MCB box separate, and separate panel for that. And you require the electricity, you need to measure the electricity cost overall, because if your electricity cost is going higher, then you require separate meter for that, so that different SLD charge can be taken to be considered. And apart from that, you have to do the civil works. You have to proper foundation for these charges. You require shades, you require painting and sign box. These are the basic guidelines when you select the site at your workplace. So this is in 1 hour I have tried to cover as much as possible, and as Mikul sir, I am going to stop over here now. Okay. Any questions? Hemali, Kush, Harshil, Sahil. How I can overcome the range problem? Oh yes, very good questions. And that is where the battery management system. The problem can be the two things, the two solutions basically. One is your battery pack, whatever battery pack you are using, if you use more battery pack, then the weight problem. So one battery pack, if you have a cell capacity, that will have a higher power density as well as higher energy density, and have a small kg weight. Let's say I have only 0.5 kg weight of my cell, and it have a very high power density as well as very high power as well as very high energy density. So that will reduce the space. So I can use one another pack, I can use third pack. So cell technology, so battery technology is one concern. If you have a good battery technology, then you can increase this range. Second, by proper maintaining the battery power, battery energy, if you are properly managing the battery energy fully, then also you can increase 5% or 10% range, not more than that, but at least you can increase 10 to 15% range by properly utilizing the battery energy overall into your vehicle. So these two things will be possible. One, if you totally change the technology of battery, then you have invented any particular battery so that it will have a higher power density at a less kg and less space, and higher energy density at lower kg and lower space, then automatically it will have a large range, because it will for in the same space you have a lot more cells and lot more power. So cell technology you to develop or battery technology you to develop, or either if you are not chemical engineer and you cannot develop the battery technology, then you have to properly utilizing the battery power in your vehicle. You efficiently driven the motor, you efficiently driven the other different parts of your vehicle. You properly maintain the charge and discharge, so that you can fully utilize the energy of this battery. So you can increase 5 to 10 to 20 15% of your range by that. Is there any are you satisfied with my answer, Harshil? Okay. Is there any thank you very much all the participants, Sahil, Kush, Harshil and Hemangi, for listening, and to have a interaction in between, and to asking the questions. And in future also, Ganpat University is delivering this much of webinar to aware the students, to aware the technocrats about the new technologies, so that they can be aware and they can be utilize these things in their knowledge or in their domain. So thank you. Thank you, Harshil, for your nice feedback. Okay, sir.